The Old Oak Bridge widening project is located in northern Parow in Cape Town. In March of 2016, the Western Cape government decided to widen the N1 highway in response to increased traffic and bottlenecks in the area. A major concrete portion of the work was the construction of a triple-spine concrete bridge across the N1.
The Old Oak Bridge widening project is part of a bigger 490 million rand project, which aims to improve traffic conditions between Plattekloof and the Old Oak on the N1. The bottlenecking of the N1 and the resulting congestion was deemed to be undesirable, and therefore the 4-year project was initiated. Although fairly standard, the concrete work over the bridge had a number of interesting features. One such being the specialized steel gantry formworks that were used to create the balustrade on the sides of the bridge. Another additional project that was needed was the lateral support to the neighboring bridge after the embankment had subsided. Widening of the western section of the Old Oak Bridge is a major undertaking which has required significant planning. However, this assignment will focus on the concrete works associated with the Old Oak Bridge.
The following section will cover the comparison between the Bill of Quantities and the SANS 1200G document. When doing this comparison, it was found that there were some deviations in the BOQ to what is required as per SANS 1200G, and this reflects the preferences of the engineers. The first major difference that we observed was the order of the items to be measured. In the SANS document for structural concrete, it is stated that formwork should be measured first, followed by reinforcement, then concrete last. However, in the BOQ, the order was concrete first, followed by formwork, then reinforcement. For the formwork section of the bill, narrow width and recess were measured in linear meter as required in the SANS 1200G. However, items other than those previously mentioned were measured in meter cube instead of meter square. We deduced that it was a typing error by looking at the quantities. Another difference for this section was that the items were not grouped by their inclination, either vertical, battered, sloping or horizontal. Rather, they were each described separately. For the reinforcement section, this BOQ followed the requirements of the SANS 1200G document for mild steel and high tensile steel. However, welded mesh reinforcement were measured in meter cube instead of meter square as required. We deduced that it was also a typing error. For the concrete section of this BOQ, the items were separated by the strength of the concrete and its position in the structure as required by the SANS 1200G document. Blinding was measured in meter cube instead of meter square, even though the thickness is stated in the description. Also, finishes such as wood floated, steel troweled, and power float were measured in meter cube instead of meter square. Another difference we observed was that the finishes on narrow width were measured in linear meter, but in the SANS 1200G document, finishes on narrow width is not measured separately from other surface finishes and therefore should be measured in meter square.
This assignment has allowed us to gain a better understanding of the SANS 1200G document with regards to measurement of concrete works. When comparing the order of measurement, the engineers often deviate from the specific order set out in SANS 1200G. As observed in comparing the Bill of Quantities with the SANS 1200G document, many of the units of measure do not comply with the recommended units. This may be in part to typing errors that were made during the compiling of the bill of quantities. In conclusion, the engineer's application of the SANS 1200G document allows for adaptation to suit individual preferences as compared to the quantity surveyor's fixed and rigid application of the model pill.